So in 5.5a, we learned the setup for what we're actually doing in 5.5b. So in 5.5b, they're going to give us a problem, something like this, and we have to find the roots. We have to find all of the roots. So first we need to remember, how do we find all of the roots, or how do we know how many roots to find? Well, there will be as many roots as the degree. Okay, so the number of roots is the same as the degree. Okay, and then the first thing you need to do is factor out a GCF if you have one. So if you have a GCF, and take it out to the front. And then after that, we are going to do list, test, rewrite. List, test, rewrite, list, test, rewrite, list, test, rewrite. It gets repetitive, and you have to do that over and over and over again until you can find all of the roots. So first thing, factor out a GCF, and then list, test, rewrite. So there are a couple steps so we make our list, and then there's a couple steps that can help us simplify that. One of them is telling how many positive real roots there might be. To do this, we count the sign changes of the original problem, or telling how many negative real roots there might be. To do this, we put -1 in for x, simplify, and then count the sign changes. And we went over how to do all of that over here. This is Descartes' rule of signs, so that's how we do all of that. And so that will tell us positive and negatives. Remember, you don't have to do that step, but it can simplify your list. So how do we get that list? Well, the list are the factors of the constant. And remember, that's the one with no variable, divided by the factors of the leading coefficient. And if this is in standard form, that's the number in front. The number in front of all of the x's and stuff. And then remember, we split the list and plus minus everything. Okay, so that is all stuff we did previously. So here's what's new. So what's new is we're going to take a number, and that number is going to be any number from this list, any number at all. It doesn't matter which one. You can pick a number, and all of your classmates can pick a different number, and no one would be wrong. You pick any number, again, any number from that list, any number from that list. And what you're going to do with that number is put it in a box and draw a line down here. Does this look kind of familiar? Well, it should. It's synthetic division, which we just did in 5.4b. So if you can't remember how to do it, go grab your 5.4b notes and review it. Okay, remember what you get in this box is the remainder, and underneath the line is the quotient or the answer. So what are we trying to find? Well, we are trying to find what's called a root or a zero. And in our 5.4b notes, which you probably don't remember because it was just kind of mentioned, we have found a root if and only if the remainder is 0. Okay, if the remainder is 0, then the number in the box is a root. Okay, and we are excited about that because that's one of our answers. So when we find how many roots is the same as degree, it's going to be 2, 3, 4. We're going to have to find a few answers. It's not just going to be one. And every time we get a 0 here, we found one, which is exciting. So remember, when you know that a number is the root, you can write it as x minus that or change the sign, and that is a factor. And we're going to need to know how to do that on our assignment. Okay, so then what is this rewrite step about? Well, what we do for rewriting is we do f of x, or you can use y, it doesn't matter. You write the factor from this number. So say this was 2, it would say x minus 2. Say it was negative 7, it would say x plus 7. So whatever that number is what goes first here. And then we have the quotient. Now, this is very, 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 very important. Very important. This is now my new problem. Okay, now I completely ignore the original problem. Completely ignore it. And I only focus on this new problem. Because if I keep going with the original problem, I'll just keep spinning my wheels and I'll have to test every single one of those numbers. And that's just not a good use of your time. So you want to step down. So once you find a root, then you want to just focus on what's left of the problem and use it. Okay, so you are going to completely ignore the old problem and repeat your list, test, rewrite using this quotient until your quotient starts with x squared. When it starts with x squared, that means it's quadratic, okay? And when you have a quadratic, when your quotient is finally quadratic, then you will find the last two roots using the quadratic formula. Okay, so quadratic formula should sound familiar because we've done it before. Let me write it down here real quick. It's x equals opposite b plus or minus the square root b squared minus 4ac divided by 2a. And if that sounds familiar, it should. It's from your 4-7 notes. Okay, 4-7 notes. That's when we learned quadratic formula. All right, let's flip this over and try some of these. So first thing you're going to do is take the problem on your paper and cross it off. Take the problem on your paper and cross it off and rewrite this one. So this is the problem I want to do because this one is closer to the ones on your Math Excel than the other one I had. So the first thing I want to do is look at how many answers do we need to find. Well, that's the same as the degree. So the degree of this problem, after you've gotten it written down, is the leading exponent, the leading term's exponent. So we have 3 answers or roots to find. 3 roots to find. So are we going to be able to just find one and be done? No, we're going to have to find 3. Okay, so we need to start making our list. So we need to look for a GCF, and I don't see a GCF. This has an X, this does not, so I don't see any GCF. So GCF, question mark, no. So then we just start with our list. So list, test, rewrite. To make our list, we need factors of the constant, which is 45, divided by factors of the leading coefficient. And there's not a number there, so it's 1. So what are the factors of 45? Well, if you don't know, you could just grab a calculator and start dividing 45. Does 45 divide by 1? Yep. Does 45 divide by 2? No, because that gives me a decimal. Does 45 divide by 3? Yes. Okay? And you would keep going until you get them all. But for speed's sake, I'm going to give them to you. 1, 3, 5, 9, 15, and 45. And the factors of 1 are just 1. And that's the only number that will only have 1 factor. Then we split this list, so plus minus in front of all of them. So how many possibilities do we have from this list now? 1, 2, 3, 4, 5, 6. 6. So we have 12 possibilities. So that's good because we went from infinity numbers to 12. So here's my list that I'm going to use. Now what I can do is pick any number from that list. Any number from that list at all. But I want to narrow it down and see if maybe there's only positive or only negative roots. So I'm going to do that possible positive roots thing. To do that, I count the sign changes. So this one doesn't have anything in front of it, so it's a plus. This one has a minus in front of it. This one has a minus in front of it. And this one has a plus in front of it. So I went from plus to minus and minus to plus. So that's 2 or 0 sign changes. And you did that a lot in your 5.5a assignment, so hopefully you know how to do that. And then the one that's a little more difficult, possible negative roots. Okay, possible negative roots. Okay, so this one is an odd, so it changes. It was plus, it becomes minus. This is an even power, so it stays. Odd power, so it changes from a minus to a plus. And this last one won't ever change. So how many sign changes do I have here? 1. Okay, now which of this is bigger? 2 or 1? Well, 2 is bigger. So we have more positive real root possibilities. Okay, and the reason for that is because 2 is bigger than 1. So we can pick any number from this list. But we are going to pick a positive number because there's more positive possibilities. And we are going to test that using synthetic division. Okay, so we're going to test that using synthetic division. So I'm going to pick an easy number. I'm going to pick 1. 1 is a super easy number. So 1 is my number, and I'm going to get my coefficient line from my original problem. So the coefficient here is 1, coefficient here is -5, coefficient here is -9, and coefficient here is 45. Okay, so now I'm going to do that. If I bring the 1 down, it's 1. Multiply by what's in the box. 1 times 1 is 1. Add down, -4. Multiply by 1, -4. -13. Multiply by 1, -13. And that is going to give me 32. So did I get what I want? No. The only thing I care about is getting a 0. So that didn't work. So let's try the next one, 3. Now, could I have tried 5, 9, 15, 45, anything like that? Yeah. Could try any of those numbers. Okay? And sometimes you're going to be a good guesser and sometimes you're not. So let's try this one. So if I bring down the 1, multiply by 3, add down, multiply by 3, add down, multiply by 3, and add down. And I'm excited now. Why am I excited? Because I found a root. Okay, so I'm going to highlight or circle. Oh, lights went out. Hang on. I'm going to highlight or circle this 3 because it is one of my answers. So I want to make sure I know where it's at. Okay, so now, am I going to go back to this problem and this list? No, do not do that. Do not do that. So what we need to do is we need to rewrite using this. So this right here is my new problem. And hopefully you remember from this that this is your remainder, this is a number, this is an x, and this is an x squared. So my new problem is x squared minus 2x minus 15. So now I can list, test, rewrite from this problem. I can list, test, rewrite from this problem. But if you notice, this is quadratic. And what did I say about the last two roots? I said when we get down to quadratic, we need to use quadratic formula. Okay, so quadratic formula, remember, is x equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. So what's your a, b, and c? Well, your a, b, and c comes from right here. A is 1, b is negative 2, and c is negative 15. Okay, so we're going to use that in my quadratic formula. So x equals opposite b, or 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 15, divided by 2 times 1. Okay, now when I taught you this before, we had those nice calculators, but they're gone now. So we have to do this more step by step. So the first thing we need to mess with is what's inside the parentheses. So the first thing we need to do is square that. So that's 4. Then we need to count these parentheses, or count these negative signs. 2 negatives make a positive. If there was only one negative, we would keep the negative, or if they all three were negatives, we would keep the negative. But 2 negatives make a positive. Then in your phone or in a little calculator, just do 4 times 1 times 15. 4 times 1 times 15 is 60. And then on the bottom, we could do 2 times 1, which is 2. Now keep working inside your parentheses. You have 4 plus 60, that's 64. And then still keep working inside our parentheses, inside our square root. The square root of 64 is 8. So now that I have it down to a single fraction, I split it. 2 plus 8 divided by 2, and 2 minus 8 divided by 2. 2 plus 8 is 10, so I have 10 over 2, which is 5. And 2 minus 8 is negative 6 over 2, so I have negative 3. So what are my roots? Well, my roots are these two that I just found and the 3 from clear up here. So when I finally write these, my roots are x equals, it has to start with x equals. So my first one is 3. Where did I get that? That came from the box. And then my next two are 5 and negative 3. And where did those come from? They came from the quadratic formula. And then the last thing is your Math Excel will make you write the factored form of the equation. Okay, so the factored form of the equation needs to always start with y equals or f of x equals. And now we change each of these to factors. So that said 3. As a factor, it will say x minus 3, because remember it changes the sign. That says 5, so as a factor, it will say x minus 5. And that says minus 3, so as a factor, it will say plus 3. Doesn't matter what order these are in, so yours can be different than one on Math Excel, and that's fine, but they all need to be there. Okay, flip it over. Here's another new one. Again, I'm changing these problems just so they're more like what you're doing on Math Excel, so write this one down. And let's see again, how many roots do we need to find? So it looks like 3. So we need to find 3 answers. GCF, I don't see one, so let's just get started with our list. So to make our list, we need the factors of the constant, which is 8, over the factors of the leading coefficient, which is 1. So 8 divides by 1, 2, 4, and 8. 1 only divides by 1. So when I make my list, I have plus minus 1, 2, 4, and 8. So that's the numbers I'm going to pick from. And possible positive roots. Looks like I have plus, plus, minus, minus, so 1. And possible negative roots. That would change the sign, that would keep the sign, that would change the sign, and that would keep the sign, 2. So it looks like this time I want to start with negative numbers. Do you have to start with negative numbers? No, you don't. But since 2 is bigger than 1, I'm going to start with negative numbers. So let's go with negative 2. Oh, that's the wrong color. Negative 2. So negative 2 is going to go in my box. My coefficient line is 1, 3, negative 6, and negative 8. And so as I complete this problem, let's do this. So 1 drops down, multiply by negative 2, add down, multiply by negative 2, add down, multiply by negative 2, and that did not give me 0. So let's pick another number. So let's pick negative 1 this time. And my coefficient line is still the same. And what color was I using? Orange, okay. 1, negative 1, 2, negative 1, negative 2, negative 8, 8, 0. Hooray, I found a root. So highlight that or circle that because you're going to need it later. And now our new problem is this, x squared minus 2x minus 8. Because remember, this is the remainder, this is the x, or this is the number, this is the x, and this is x squared. And since it looks like this new problem is quadratic, I'm going to go ahead and do quadratic formula again. A is 1, B is negative 2, and C is a negative 8. So it will be x equals opposite negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 8 divided by 2 times a. So then we have in here, we need to do negative 2 squared. Negative 2 squared is 4 minus 4 times 1 times negative 8. Okay, divided by 2. Okay, so when we have this next step, we need to count our negatives. So I have 4, I have a negative and another negative. 2 negatives make a positive. And then I do 4 times 1, which is 1. 1 times 8, which is 32. So notice when I was multiplying those, I ignored the negative signs. So that's what you do. You count the negatives to figure out if this is a plus or a minus, and then you just multiply them without their negatives to get this number. Okay, 4 plus 32 is 36. So I have 2 plus or minus the square root of 36 over 2. 36 nicely is a perfect square. So we can take the square root of that and get 6. And then look again, we have this ready to split. So 2 plus 6 divided by 2, and 2 minus 6 divided by 2. 2 plus 6 is 8. 8 divided by 2 is 4. 2 minus 6 is negative 4 divided by 2 is negative 2. So my roots or answers are, remember it always starts with x equals. I had negative 1 from my box, and from the quadratic formula I just got 4 and negative 2. And then to rewrite that as the equation, I do y equals or f of x equals, and then we change the sign. So x plus 1, x minus 4, and x plus 2. All right, and one more, and then, all right, last one. And again, a new problem than what was on your notes, but again, I'm doing that so they're more like the ones on Math Excel, because Math Excel didn't have big numbers really like that. So on this one, again, we look to see how many answers we need to find. So we need to find 3 answers because it's the same as the degree. So next we look for a GCF, and I don't see one, so no GCF. So we start our list. To do our list, we do factors of the constant, which is 20, over factors of the leading coefficient, which is 1. Oops, ignore that bell. So 20 divides by 1, 2, 4, 5, 10, and 20. And 1 divides by 1. So when I split that, I have all of these numbers with a plus minus in front of them. And this is more than we've had for a while, so hopefully we can be a good guesser. How many possible positive roots do we have? We have a positive, a negative, so that looks like 1. And how many possible negative roots do we have? Negative, positive, negative.
Please step by the front office.
So that looks like we have two negative roots. So let's start with a negative number. Let's see. Let's go kind of small. So let's pick -2. All right, -2. Put that in your box, and then get your coefficient line. 1, 5, -4, -20. And then we test using synthetic division. So test 1, -2, 3, -6, -10, and 20. So, ooh, I'm a good guesser. Yes. So sometimes you're going to be a good guesser and you're going to get it on the very first try. Other times you're not going to be a good guesser and you're going to have to test 2 or 3 of them before you get the right answer. Okay, so remember we highlight that or star it or whatever because that's one of our answers. And we go on and use our new problem. So my new problem, this is the remainder. This is the number. This is the x, and this is x squared. So we have x squared plus 3x minus 10, and this is quadratic, so we're going to use the quadratic formula. A is 1, B is 3, and C is -10. So we have x equals opposite B plus or minus the square root of B squared minus 4 times A times C divided by 2 times A. So we work inside that square root first. Square root of 3 is 9. And then we can count the negatives. There are 2 of them. That makes it positive. And I know that's happened on every problem in your notes, so please don't think that's a pattern. It's just because there's 2 negatives. So now we ignore the negatives and we multiply. 4 times 1 times 10 is 40. So we can add that. 9 plus 40 is 49. And then we take the square root. The square root of 49 is 7. And now that I have none of that in the square root anymore, I split it. -3 plus 7 divided by 2 and -3 minus 7 divided by 2. So that gives me 4 divided by 2, which is 2. This gives me -10 divided by 2, which is -5. So my roots, and remember these always start with x equals. So my roots are x equals. I got -2 from in my box, and I got x equals 2 and x equals -5 from my quadratic formula. So that's the roots. And then the factored form of the equation, remember that always needs to start with y or f of x. Again, ignore the bell, sorry. And we change the sign to get this. So it's going to be x plus 2, x minus 2, and x plus 5. So that is all we've got. So go ahead and work on 5.5b and let me know if you have any questions.